Lesson 12.4 is a study of the relationship between certain types of lines. And I'm going to start with the graph and jump in right away to question number 1. Notice that we have L1 and L2. And when we label lines, we often use a lowercase letter, and then this little number is called a subscript. So it's kind of like thing 1 and thing 2 from the Dr. Seuss book. We have L1 here and L2, and over here we have L3 and L4. But we want to look and see what the relationship is between these lines. If I choose these 2 points, I notice that the slope here is equal to 1/2. And if I find the slope of L2, I also notice that the slope is 1/2. And if we have 2 lines that have the same slope, if I extended these forever and ever and ever, they would not intersect. We say that these 2 lines are parallel. Now, for L3 and L4, they have a different slope. They have a negative slope, actually. And if I choose these 2 points, I see that the slope here is -2/3. So for L4, the slope is -2/3. And for L3, we also notice that it is -2/3. This is -2/3. And you can see that if these have the same slope, if you extend them, they would also never touch, or they would never intersect. Now, determine the slope of each line. Well, these 2 have a slope of -2/3, and these 2 have a slope of 1/2. Now, looking at this graph, I think it's fair to say here that if lines have the same slope, lines which have the same slope are parallel. Now, it's important to note that we're talking about distinct lines. We could have one line on top of another one, and those 2 lines would have the same slope, but they are essentially the same line. So when we're talking about lines having the same slope and being parallel, we're talking specifically about distinct lines. Now, in number 3, determine the slope of a line that is parallel. Now, parallel means that if we're using the relationship here, then parallel means it has to have the same slope. Different line, but the same slope. And we notice that this line has a slope of -3. So if we want the slope of a line parallel to this line, its slope would also have to be -3. Now, it would have to have a different intercept to be a different line, but it would have to have the same slope. So we could have a line, say, -3x plus 5. Same slope, different intercept, parallel to this one. It could also be y equals -3x minus 8. So same slope, different intercept, parallel. Number 4, we're asked to write the equation of a line that is parallel to this line and has a y-intercept of 5. So if the y-intercept is 5, then we're going to have a plus 5 here at the end, but we want the slope to be the same because we want it to be parallel. So that would be 3/4 x plus 5. Now, if we turn the page to the second side here, we have horizontal lines are described by equations of the form y equals a constant. For example, the equation of the x-axis is y equals 0 because all points on the x-axis have a y-coordinate of 0. Now, horizontal lines are parallel because they all have a slope of 0. Now, for number 6, vertical lines are described by x equals. Now, x equals 2, or x equals 5, or x equals -1. Okay? Now, the equation of the y-axis is x equals 0 because all the points on the y-axis have an x-coordinate of 0. Now, do you think any two vertical lines are parallel? Well, any vertical line would be a slope that is undefined. So if we have our xy coordinate plane like this, any vertical line here would have a slope that is undefined. Actually, it does not have any slope, but we say that it is undefined. Two vertical lines are parallel. So any two vertical lines that are distinct lines, not landing on top of one another, those would also be parallel. Now, in number